Hey everyone, and welcome back to the channel. Today, we are taking something you probably have lying around your house, the humble rubber band, and turning it into an awesome DIY launcher. We're going to build this incredible contraption using just some basic craft supplies, cardboard, a bunch of rubber bands, and a plastic spoon. That's right, we're building our very own mini catapult, and the best part, we're going to learn some cool science along the way, exploring concepts like tension, force, and trajectory. You'll be amazed at how a few simple materials can create something so powerful and fun. So grab your supplies and let's get ready to build, launch, and learn. First things first, let's gather our materials. You won't need anything fancy for this project. The main components are some sturdy cardboard. Then old shipping box works perfectly. We'll also need a handful of rubber bands of various sizes, a simple plastic spoon, and a hot glue gun with some extra glue sticks. For our targets, you can get creative. We'll be using some stacked plastic cups, but you could also use empty soda cans or even some little toy figures. And of course, we need ammunition. I recommend using something soft and light, like small paper balls, pom-poms, or even marshmallows. Safety first, so make sure whatever you launch won't cause any damage. Got everything? Great. Let's move on to the first step of our build. Our launcher's foundation is the base, and it needs to be strong and stable. Take your cardboard and cut out to identical rectangular pieces. A good size to start with is about 8 inches long and 4 inches wide. These will form the bottom of our launcher. Now apply a generous amount of hot glue to one of the pieces and firmly press the other one on top. This doubles the thickness and makes our base super sturdy, so it won't wobble when we start launching things. Set that aside for a moment to let the glue completely cool and set. Next, we need to build the support arms. These are the pillars that will hold our launching mechanism. From your cardboard, cut for identical rectangular pieces. Let's make these about 6 inches tall and 2 inches wide. Just like we did with the base, we're going to double them up for strength. Glue two pieces together to create one thick support arm, and then do the same with the other two pieces. Now, you should have two strong, identical support arms ready to go. Make sure they are nice and flat while the glue dries. These arms are crucial because they'll be handling all the tension from our rubber bands. Now, it's time to attach the support arms to the base. Take your sturdy base and one of the support arms. We're going to glue the arm upright at one end of the base. Stand it up vertically, right on the edge. Apply a good line of hot glue along the bottom edge of the arm and press it firmly onto the base. Hold it in place for about 30 seconds until the glue starts to set. To make it even more secure, add some extra glue along the sides where the arm meets the base, creating a reinforced joint. Repeat this exact same process with the second support arm on the opposite end of the base. You should now have what looks like a miniature, wide goalpost. Let it sit for a few minutes to ensure the glue is completely solid. With our frame built, it's time to create the launching arm itself. This is where the spoon comes in. The spoon will act as the bucket of our catapult. Take your plastic spoon and we're going to attach it to a cardboard strip. Cut a piece of cardboard that's slightly narrower than the distance between your two support arms and about 5 inches long. Now place the spoon at one end of this cardboard strip so the handle rests along the cardboard. Secure it tightly with a generous amount of hot glue. Make sure it's really stuck on there because this joint will take a lot of force. This combination of the spoon and the cardboard strip is our official launching arm. Let's install the launching arm into our frame. We need it to pivot freely. To do this, we'll use another piece of cardboard as an axle. Cut a small, thin strip of cardboard, about 1 inch wide and long enough to pass through both support arms. Now, carefully poke a hole through the center of each support arm, about 1 inch up from the base. Make sure the holes are aligned. Then poke a corresponding hole at the bottom of your launching arm, the end without the spoon. Gently thread your cardboard axle through one support arm, then through the launching arm, and finally through the other support arm. It should be snug but still allow the launching arm to swing up and down smoothly. You can add a tiny dab of glue on the outside of the axle to keep it from slipping out, but be careful not to glue the arm itself. Now for the power source, the rubber bands. This is what will give our launcher its launching power. We're going to stretch a few rubber bands from the top of the support arms down to the launching arm. Take 1 or 2 rubber bands and loop them over the top of one support arm. Stretch them down and hook them onto the launching arm, close to the spoon. Do the same thing on the other side. You've now created the tension system. When you pull the launching arm back, the rubber bands will stretch, storing potential energy. When you release it, that energy converts into kinetic energy, flinging the arm forward. Let's test it out and talk about the science. Set up your targets a few feet away. Place a soft projectile, like a pom-pom, into the spoon. Gently pull the spoon back, hold the base steady with one hand, and let go. Watch it fly. Pretty cool, right? What's happening here is physics in action. The further you pull the arm back, the more potential energy is stored in the stretched rubber bands. This is called tension. When you release it, the rubber bands snap back, transferring that energy to the arm and launching your projectile. The path your pom-pom takes through the air is its trajectory, which is affected by the launch angle and the force. Now, let's experiment. This is how we can improve our accuracy and distance. What happens if you add more rubber bands? Try adding another one on each side. You should notice that it's harder to pull back, but the projectile flies much farther and faster. That's because more rubber bands mean more stored potential energy, resulting in a more powerful launch. What if you change the angle? Try launching with the arm pulled back only slightly versus pulling it back all the way. A lower angle launch might be good for close targets, while a higher angle launch is better for hitting something far away. Keep adjusting and see if you can hit your targets consistently. Let's try another variable. What about the projectile itself? Let's compare launching a light pom-pom versus a slightly heavier marshmallow. The same amount of force will launch the lighter object faster and farther. This demonstrates Newton's second law of motion. Force equals mass times acceleration. A heavier object requires more force to achieve the same acceleration. You can even try launching to different objects at the same time to see the difference. Keep a little notebook and write down your findings. Which combination of rubber bands, launch angle, and projectile works best for hitting a target 5 feet away? How about 10 feet away? This is how real engineers think. This simple cardboard launcher, an amazing tool for understanding some really important physics principles. We've seen how stored energy, or potential energy, in the rubber bands is converted into motion, or kinetic energy. We've learned that changing the force by adding more rubber bands directly impacts the launch distance. And we've thus seen how the mass of the projectile and the launch angle both play a huge role in determining the trajectory. It's a perfect example of how science isn't just in textbooks. It's in everything we do, even in a fun toy made from cardboard and a spoon. I hope this project has sparked your curiosity to build, experiment, and discover more about the world around you. And there you have it, your very own super cool, super fun DIY rubber band launcher. We built it from scratch, launched some stuff, and learned a ton about physics along the way. I hope you had as much fun building this as I did. If you made your own launcher, I'd love to see it. Share a picture or video on social media and tag us. What other fun science projects would you like to see us build next? Let me know in the comments below. Thanks so much for watching, and don't forget to like this video and subscribe for more awesome DIY projects. Until next time, stay curious and keep building.